Good morning, dear students. We have already seen the light reflection and refraction. Last class that we have studied the rules for image formation for convex lenses. Okay. Now we are going to see the image formation for convex lenses. How the image is formed in the convex lens. That is what we are going to discuss it now. Okay. So as you can see here, the image is kept in a 6 different positions. As we have already studied for the mirror, in this lens also, the object is kept at 6 different positions. Okay, what are the 6 different positions? And if the object is kept, how the image is formed, and what are the how the rules is applicable here? Everything we are going to discuss it here now. Okay, first, the object is at infinity. Infinity means is nothing but a distance object. For example, a long distance, a tree is there, or a building is there, like this. Some long distance object that we will take it here, and we will consider this as a object at infinity. Okay. So the object is considered as A and B here. Can you see the diagram? A and B is the object. The light rays coming parallel to the principal axis. This is principal axis. Okay. This is optical center. This is principal axis. Okay. The light ray coming parallel to the principal axis. When it hits the lens, after refraction, it converges in, passes through the focus. Or when the light ray parallel to the principal axis, it passes through the second focus. That is what we have studied for rules for image formation. So in this diagram, all the rays coming parallel to the principal axis passes through the focus. So where all the rays meets together, there the image is formed. Image is considered as the point object or very, very small image. Okay. It is the image which is formed is real and inverted. Okay. And in the second position, the object is kept beyond C. That is, here C is considered as 2F. This is focus 1, this is focus 2. This is center of curvature 1, center of curvature 2. Twice the focus is called center of curvature. That is why it is 2F1. It is written over there. Beyond C, beyond 2F, the object is kept. Object is A and B. Okay, the arrow mark is given as object is erect. So the ray which is going parallel to the principal axis hits the lens and it passes through the second focus and it is going over here. And one more light ray which is going through the optical center without any deviation, it crossing over here. These two rays meets at a particular point where the image is formed. The image formed as inverted. Inverted means it is B dash A dash. Here A, B, here B dash A dash. It is formed. So if the object is kept at beyond C, where the image is formed between C and F on the second side, on the other side. Object is kept at one side, image is formed on the other side. In mirror, if you recall it, where the object is kept, image is formed on the same side. But in the lenses, the image is formed on the other side. Okay, hope you understand this. Okay, next we are going to see the next position of the image. And one more thing here, you should understand from distance between the optical center and the first focus is called F. The second focus is called F. F means focal length. And this, from optical center where the object is kept, the distance between object and the optical center is called object distance U. The distance between the optical center and the image is called image distance V. Okay, so this is the second diagram. And when it comes to third diagram, you can see here, object is kept at C. At C, the object is kept. A and B shows that it is a erect, straight object. When the light ray goes parallel to the principal axis, after refraction, it passes through the second focus and goes straight here. And another ray goes through the optical center without any deviation, it goes. Both are meets at a particular point where the image is formed. So where the image is formed at C on the other side, second center of curvature. Here 2F on the one side, same 2F, the image is formed. It is real and inverted. And in the rules formation that we have already seen, when the light ray passes through the optical center without any refraction, without any deviation, it goes on the straight line. Right? That is what the rules which is applicable here. Okay. And next position, the object is kept between focus and the center of curvature. The object is straight, erect. Okay. So A and B. One ray goes parallel to the principal axis, and after refraction passes through the second focus and goes straight. Another ray goes through the optical center without any deviation. It goes and meets over here. So where it meets, there the image is formed. Okay, image is inverted and it is enlarged. Can you see here? The object is small in size, image is big in size. So enlarged, inverted image that we can get it. It is a real one. But when in this position, object size and image size both are same. As we have already studied for concave mirror, object size and image size will be same. Okay, and we'll go for the next position. Next position is the object is kept at focus. Object is kept at focus, erect object, arrow mark is given here, AB. One parallel light goes straight and hits the lens and goes to the second focus. And another ray goes through the optical center without any deviation, it goes straight. These two rays are parallel to each other, so it will not meet at any point. So the object, so image which is captured at infinitive. So if we keep the object at focus, the image is captured at the infinitive. It is the similar thing that of a first one. Object is at infinity means image is at focus. Here image is at object is at focus means image is at infinitive. Okay. Similarly, next one, the object is kept at between optical center and the focus. Between optical center and then the focus, if we keep it, what will happen? One light ray goes parallel to the principal axis. After refraction, goes through the second focus. Second ray goes through the optical center without any deviation, it goes. These two rays are without meeting, diverges and goes. So we cannot capture the image at a particular point. So what we will do, we will extend the backside of the refracted image, refracted ray. Backside, if you extend it on this, it will meet, both are met at one particular point. Here the image is formed. Can you see the image which is drawn in a dotted line? This line is also considered as a dotted line. Dotted line means here imaginary erect image is formed. So size of the image is also enlarged compared to the object. Okay, hope you understand the 6 different diagrams. First, object is at infinity means image formed at focus. Second one, object at beyond C means image formed between C and F. Okay, there will be, and object is at C means image is also at C, and it is a reverse of this, where the object is kept between C and F means image is captured beyond C. It is a reverse of the second diagram. Okay, and the third one, object kept at focus means image formed at infinitive. Object kept between focus and the optical center, image formed is on the back side of, on the same side of the lens. Okay, I hope you understand this. Now you can see the image formation by convex lens in the table form. The position is given and the position of the object is given, position of the image is given, size of the image, how it is, and nature of the image is also given. As you can see here, at infinitive, if the object is kept, image formed at F2. Okay, as we can see in the diagram. Okay, image is formed at F2. And the point sized image that we can get it, it is a real and inverted one. Okay, and in the second diagram, object is kept beyond 2F1, image is captured between F2 and 2F2. Can you see here? Beyond 2F1, between F2 and 2F2. It is a diminished size of image, real and inverted. Next one, object is kept at 2F1, image is formed at 2F2. Object 2F at 2F1, image at 2F2. same size, real and inverted. It is the same size and real and inverted. And next one, between f1 and 2f1 the object is kept. The image is found beyond 2f2. Between f1 to f1 the object is kept. Image is found beyond 2f2, and the size of the image is enlarged. Compared to the object, the image is enlarged. Real and inverted. And at f1 focus, image is at infinitive, highly enlarged, because it's highly enlarged image that you will get it. And real and inverted. Between f1 and o, between f1 focus and the optical center, if it is kept, means it is beyond 2f1. That is on the same side of the object, enlarged image that we can get it. It is virtual because it is erect, virtual and erect image that we can get it. Okay. And image formation of the concave lens that we will see in the next video. Thank you.